Remember in the last section how we talked about integral can be used to represent area under the curve? All right, let's look at this part first of all. Analyzing the velocity versus time curve. Let's suppose we have the velocity versus time curve, and I forgot to put a v-axis right here, okay? Let's suppose I want to calculate, if I'm given a drawing like this, let's say, the displacement from t subscript to 0 to t subscript to 1, okay? And this is area 1, that's area 2, that's area 3, okay? What does it tell me for the displacement between t subscript to 0 and t subscript to 1? You take area 1, you subtract out area 2, and you add area 3. Or you could think of it as, this is already a negative area, A2, so you just add them all up, okay? And that's what we call the net signed area, whenever we consider the positives and the negatives and add them up. All right, if I want the distance traveled from t subscript to 0 to t subscript to 1, and I'm given the velocity function here, what do? I take A1, add that area, add the area of A2, and add the area of A3. Now your book writes it this way. I kind of like thinking of it this way. Take the absolute values of each one of these and add them up, okay? And we don't have to really do anything if it's a positive area with the absolute value, okay? And I kind of like this. I kind of like thinking of this as adding all these areas right here, but we know that that one's negative because it's under the, x-axis. All right, so for displacement, add them all up, consider the negatives, which we call the net signed area. For distance traveled, add up the absolute values, which we call the total area. All right, this example, given a velocity versus time curve right here, okay? Find the displacement and the distance traveled by the particle over the time interval from 0 to 9 right here, okay? All right, so I want to find the what? I want to find the displacement. All right, so we've been told the displacement is what? It's really what? The integral from 0 to 9, v of t dt, right? So if we're looking at integration, we're looking at area under a curve between 0 and 9, or area between the curve and the x-axis. But we could use this. I mean, we could break it down and find the equation of this line, find the equation of that line, find the equation of that line, and integrate all those parts separately. But this tells us right here that for displacement, just add up all your areas that you have here. So let's do it this way for displacement. Let's add up all the areas here, okay? So what I could do, one way I could do this, there are multiple ways to do it, but one way I could do this is I could split this up, okay? I could say, let's find this area right here of this triangle. Then I could say, let's split up here and let's find the area of this rectangle. Then I could say, let's find the area of this triangle. And then let's find the area of this triangle right here and add all those up. That's one way you could do it. You could break it up differently. It really doesn't matter. All right, so what am I going to do? I'm going to find this first area right here. How do I find the area of that figure? If it's a triangle, it's 1/2 base times the height, right? Well, what's the base length here from 0 to 3? 3. What's the height here? 4. So I have this area, right? Have that done. Plus, let's find the area of this rectangle. How do I find the area of a rectangle? Length times width, right? Well, what's my width here? From 3 to 6 is 3 units. What's my length? My length is here, which is what? 4 units. Plus, let's find the area of this triangle, okay? Now, this goes through the x-axis halfway between 6 and 9. How do I find that halfway point? Take 6 plus 9 and divide by 2, right? What does that give me? 15 halves. So this point is 15 halves, right? What is 15 halves as a mixed number? What is that? Like 2 times what gets you close to 15? 7.5? So how wide is this triangle right here? What is the base length right here? From 6 to 7.5. 1.5, right? So how do I calculate the area of a triangle? 1/2 base times height. We just said the base was 1.5, right? Times the height is what? 4? Plus the area of your last triangle right here. So again, that's 1/2 base times height, right? What is your base? From 7.5 right here to 9. That'd be 1.5 again, right? Times your height. What's your height this time? -4, right? All right, so now you just calculate that stuff. Now just calculate that stuff. Let's see. What is that going to give me? Well, 1/2 of 4 is what? 2. 2 times 3 is 6. Plus, what does this give me? 12. Now look at this right here, okay? This is the same thing as this part right here, but one of them's going to be positive and the other one's going to end up being what? Negative, so they just zero each other out. Well, what does this give me? 18, right? Now, do I have any units given to me here? No. So I just have to put 18. I don't know if it's inches, feet, meters, centimeters, miles, or what. All right, so I found what? The displacement, but I still need to find what? The distance traveled. Distance is what? The integral from 0 to 9 of the absolute value of the velocity, right? Or better yet, if I'm given a picture, I could say this. Just take the absolute value of each one of those areas and add them up, right? So what did this area look like? That looked like what? 1/2, 3 times 4, right? Take the absolute value of it. Plus, what did the area of this rectangle look like? It looked like 4 times 3, right? Take the absolute value of it. Plus, what did the area of this triangle look like? It looked like 1/2 times 1.5 times 4, right? Take the absolute value of it. Plus the absolute value of this area right here. Well, what was this area? This area was what? 1/2 times 1.5 times -4, and take the absolute value of it. Now let's add that stuff up. Let's add that stuff up. The total area there is what they call it. Well, what does this give me? 2 times 3 is 6, right? Or the absolute value is 6, plus, this is the absolute value of 12 here, plus the absolute value of what? All right, what is this? This is really what, 3/2? So what do I have? I have 1/2 times 3/2 times 4 in here, right? So what does that give me? 3 in the absolute value? Plus, what does this give me? That's the same thing as this, right? But it's going to be a negative, so that gives me -3 in the inside of those absolute values. Absolute value of 6 is 6, absolute value of 12 is 12, absolute value of 3 is 3, absolute value of -3 is 3, right? So what does that give you? 18 plus how much more? 6, so that's what? 24, and whatever the units are here, which they never give me.